This is the introductory video of the final year project titled Graph Automorphism over Social Network. Due to the fact that social networks are usually symmetry-rich, we chose to study how graph automorphism can be applied to influence maximization. We believe that by automorphism, we can have more substitutes of the C set as automorphism nodes are structural equivalent. With these substitutes, we are especially interested in whether we can prune the original C set, because pruning the set can have many real-world implications. For example, for brand promotion, it can save the cost as fewer KOLs are needed to achieve approximation influence. We developed a visualization tool to support our study on graph automorphism and influence maximization, which can handle large graph real-time rendering, influence maximization in simulation, and it is equipped with both benchmark methods and our initiatives in symmetric subgraph matching and influence maximization. Next is our demo part of our application. Our application is an advanced massive graph visualization system. To start with, we need to upload a file containing the graph data. Here we use Facebook dataset for our demonstration. After uploading the file, we can access our visualization analysis page. The UI consists of 3 major components, including our floating toolbar at the corner of top right, which handles most of the user interactions, the container of original full graph on the right-hand side, and the modular customizable interface on the left-hand side. We leveraged a GPU-accelerated visualization framework called Cosmos, which provides the functionality to render millions of nodes in real time efficiently. We can zoom in and zoom out to explore local and global structures of the full graph. Users can also click on different nodes to trigger node-wise events. We can utilize the left-hand side to add different windows of various sizes for our own purposes. Currently, there are 5 types of windows. K-neighbor window shows k-nearest neighbors of user-selected node. You can change the value of k in the toolbar, and relevant matrices are shown correspondingly. Matrices report window summarizes all the statistics the system has analyzed so far. You can also find this data in different panels of our toolbar. For example, in Basic, you can see number of nodes and ages, average degree, etc. Degree distribution window plots both degree distribution of the full graph and symmetric subgraph pairs. An extra button is shown on top left, which includes more helper functions. We also provide the visualization of AutoTree for those who are familiar with this algorithm. In real practice, we found that the root tree node of the original AutoTree contains too many leaf nodes, as we call asteroid, which have few usages in terms of the data analysis. Therefore, we can destroy the asteroid and enjoy a clean view of the tree. It is helpful in finding symmetries. Let us render the SSM first. We can see that each symmetric subgraph pair in the full graph has been highlighted using the same color, respectively. We can also click a tree node of the auto tree, and the graph will focus on the specific pair which is represented by this tree node. If you want to go back to the default color style, just click Render Basic here, and we get the initial one colored by the degrees of nodes. Now for the influence maximization part, we use the benchmark method called PMC as well as our own pruning method for node selection and spread probability of 20% for the default IM rendering. Click Render IM and we can view the influence spread step by step. You can use these toggles to highlight the nodes in the corresponding rounds. Stepwise matrices are shown on the left. which tells us the influenced nodes in a specific round. If you want to customize your node selection, you can either type in the IDs of nodes or just click them on the graph, and it will be added automatically. If we do not select Use Original Graph, then this query will be processed in a new window for comparison. So let us add the customized IM window. Once the result is returned, you can compare the stepwise and overall performance of different approaches under different conditions using these two containers, and you can view the spread animation in real time. At last, if you are not satisfied with current layout of any graph, you can select the corresponding graph window and change all the parameters easily. The framework will calculate the new layout according to the parameters efficiently. This is the end of our demo. Thank you very much.